tutorial on prime and composite numbers. In today's video, we're going to talk about the differences between prime and composite numbers, and we're also going to be talking about factors, which are a really important part of prime and composite numbers. I hope you're ready to get started. Let's go. Before we can really understand what prime and composite numbers are, we have to know what factors are. Factors are numbers that you multiply to get another number. Let's look at the number 6. 3 times 2 equals 6. These numbers that you multiplied are the factors of 6. It's what times what will give you 6. So now that we're thinking about 6, there's another option. What times what could give you 6? 1 times 6 can give you 6. That's all the combinations that you can multiply to get 6. So the factors for 6 are 1, 2, 3, and 6. So 6 has 4 factors. Another example we could look at is 12. What times what could give you 12? 1 times anything will give you itself. So 1 times 12 is 12. There's a couple more options that we have. There's 2 times 6, and there's 3 times 4. So the factors for 12 would be 1, 2, 3, 4, 6, and 12. So 12 actually has 1, 2, 3, 4, 5. 12 actually has 6 factors. We always want to make sure we put our factors in order so we know what we're looking at. So I put them in chronological order. And if you need more practice with factors or you need a more thorough explanation of factors, I have a video called Factor Rainbows that you might be interested in looking at. All right, so let's go ahead and get on to prime and composite numbers. Prime numbers have exactly 2 factors. So that means when we're thinking about factors, what times what gives you a number. Let's start with the prime number 5. If we think about what times what gives you 5, the only answer is 1 times 5. There's no other whole number combination. Now, you could say, for instance, 2.5 times 2 will give you 5. However, this is not a whole number. It's a decimal number, so it doesn't count. We can only look at whole numbers when talking about prime and composite. 7 is another number. If you think about what times what can give you 7, only 1 times 7 gives you 7. There's no other combination of numbers you can multiply. When this is the case, when there's only a 1 times itself, these are prime numbers. Some other examples of prime numbers would be 13. You can only say 1 times 13 to get 13. 17, 23, 31, 37, 41. The list really goes on and on and on, surprisingly enough. So just as a quick recap, prime numbers have exactly 2 factors. And the factors that they're going to have are always 1 and itself. Now that we know what prime numbers are, that they have exactly 2 factors, let's look at what composite numbers may be. Composite numbers have more than 2 factors. So let's look at 4, for example. When we think about what we could multiply to get 4, the first thing that comes to my mind is 2 times 2. And of course, there's always 1 times itself. And that's it. Those are the only combinations for 4. So our factors are 1, 2, and 4. Just a quick note, if you have doubles in your multiplication, you only ever just say it once. It would be redundant if you put 2 2's in the factor list. So this has 3 factors, which is more than 2. So this is a composite number. 4 is composite. Another number would be 15. We have 1 times 15 to get 15. And we also have 3 times 5 to give you 15. So in this case, we have 1, 3, 5, and 15 as factors. That's more than 2, so 15 is a composite number. In order for numbers to be composite, they have to have more than 2 factors. Prime numbers have to have exactly 2 factors. So we're going to go ahead and look at some examples to see if we can't sort out which numbers are prime and which numbers are composite. So we're starting with 12. Start with that 1 times 12. Will give you 12. Another set of numbers is 2 times 6, and then you have 3 times 4. All these numbers tell me this is a composite number. Okay, let's look at number 21. 1 times 21, and we also have 3 times 7. That's 4 factors, composite. Number 2, the only way to get number 2 is 1 times itself. Only 2 factors means prime. 11. 1 times 11, that means it's prime. 9. We have 1 times 9, but we also have 3 times 3. That is composite. Let's talk about 2 numbers that do not fit into these categories of prime and composite. 1 and 0 are neither prime nor composite, and let's talk about why. To get the number 1, there's only one way to get number 1, and that is 1 times 1. We talked about those double factors and how you only count them once, so the only factor for 1 is 1. There's only one factor. To be a prime number, you have to have exactly 2 factors. So 1 can't be prime, and it can't be composite because it doesn't have more than 2 factors. So 1 is not prime and not composite. When we look at 0, any number times 0 will give you 0. So you could say 1 times 0 is 0. You could say 2 times 0 is 0. You could say 1,000,000 times 0 is 0. So 0 actually has an infinite number of factors. Everything's a factor of 0 because when you multiply by 0, you get 0. So these 2 numbers don't fit into the categories of prime or composite. Let's look at a different way of describing prime and composite numbers. Okay, so here I have some listed numbers. A way to look at this is by creating rectangles. If I wanted to create a rectangle with 2 boxes, there's only one way I could configure that. It would be a 1 by 2 rectangle. There's 1 and 2. Now you could put it on its side like this. However, you're still doing the same thing by saying 1 by 2. So there's only one shape rectangle you could make for 2. For 7, there's only one way you could make a rectangle. 1 by 7. If I tried to make something other than that with 7, it would end up looking like something like this. That's 7 boxes, but it's not a rectangle. Same thing with 11. I would have to go only 1 over and 11 down. But if we look at composite numbers, if I wanted to do 4, I could certainly say 1 by 4. That would give me 4. But then you could also do your 2 by 2. It really relates back to those multiplication problems. Those are 2 different rectangles that both give us 4. Let's think about 9 for a second. That gives me 9, but then we also have our 3 by 3 that we could draw. which also has 9 boxes in it. 12 has even more. You could do your 1 by 12, or you could do 3 by 4, or you could even do 2 by 6. And all those rectangles that I just drew have 12 boxes inside of them, and they're all rectangles. So that's another way to look at it. The only way to make a prime rectangle would be 1 times itself, whereas the composite numbers have several ways to do it, just like the multiplication facts. Let's go ahead and review all our rules for prime and composite numbers. First, prime numbers have exactly 2 factors, 1 in itself. Not 3 factors, not 1 factor, it has to have exactly 2. So some examples of that: 3, 1 times 3, 7, only 1 times 7, and 13, 1 times 13. There's no other combination of numbers that can be multiplied to give you those numbers. Composite numbers have more than 2 factors. So some examples for that would be 4. You have 2 times 2 and 1 times 4. So your factors are 1, 2, and 4. We have 9. We've got 1 times 9 and 3 times 3. More than 2 factors. And 12, we have 1 times 12, 2 times 6, and 3 times 4. Finally, the numbers 1 and 0 are neither prime nor composite. 1 only has 1 factor, so that doesn't fit into exactly 2, and it doesn't fit into more than 2. And then 0 has an infinite number of factors. Let's look at some extra tips. In 5th grade, you're responsible for determining if a number is prime, composite, or neither from 1 to 100. I have a video tutorial that takes you step by step in making a prime and composite chart. It's really helpful because it's hard memorizing all the numbers and if they're prime or composite. So go ahead and check that out. Also, if you need a little help with factors, you can take a look at my Factor Rainbow tutorial for some extra guidance. I really hope you enjoyed this tutorial. Good luck with your prime and composite numbers, and I'll see you next time.